everyone, Tina here, and today I'd like to talk about differentiating trig functions, exponentials, and logarithms. You'll usually come across these topics during year 2 of your A-level course. I have made other videos on differentiation, so I'd recommend you watch those ones as well. I'll show you the rules for differentiating trig functions, exponentials, and logarithms, and then we'll go through some examples. So let's start with differentiating trigonometric functions. There are a couple of derivatives which you'll need to learn off by heart, and those are that when y equals sine x, dy dx equals cos x, and if y equals cos x, then dy dx is minus sine x. Then there are some that are given in your formula book, which you can use as and when you need to. And those might look something like this. This is taken from the Edexcel formula book, but there'll be something similar no matter what exam board you're using. If we now look at differentiating exponential and logarithmic functions, all of these you need to learn off by heart. So when y is equal to e to the power of x, dy dx stays the same. It's still e to the power of x. If y is equal to a to the power of x though, then dy dx is equal to a to the power of x times ln a. The first result is actually just an application of this second result. I'll show you why. Because another way of writing dy dx would be e to the x ln e, and then ln of e is just 1, or you can think about it as cancelling each other out because they're inverses of each other, so you just end up with e to the power of x. Last result to learn is that if y equals ln x, then dy dx is 1 over x. That's it for the rules, so now I have 3 examples to work through. Example 1. The point P lies on the curve with equation y equals cosec x plus cos 2x with x coordinate pi over 4. Find an equation of the tangent to the curve at the point P. So if we look at the function we're trying to differentiate, we've got y equals cosec x plus cos 2x. Now for the part that has the cosec x, you can refer to your formula book. If we look at that, we can see that we're told what the derivative of cosec is. It's minus cosec cot. And then for the cos 2x part, you might want to do a chain rule for this. You could say y equals cos u, where u equals 2x. dy du is minus sine u, and that's the result we said we needed to memorize earlier. And then du dx is just 2. Therefore, chain rule says dy dx is those two times together. We'll get minus 2 sine u, where u is 2x, so minus 2 sine 2x. Putting that all together for the main dy dx then would be dy dx equals minus cosec x cot x minus 2 sine 2x. Now in this scenario, k is just equal to 1. That's why I didn't write anything in the derivative there for k. So now we've differentiated, and that's our derivative. We can go ahead and look at the question again. We want an equation of the tangent at a specific point. So at this point, I would sub in the x value into dy dx. So when x equals pi over 4, dy dx would be equal to this. Typing that carefully into your calculator, you'll get minus root 2 minus 2. Just a reminder here that cosec x is 1 over sine x, and cot x is 1 over tan x. In order to find the full equation of the tangent, we also need the y coordinate at that point. So let's sub in pi over 4 into the original y equation as well, and we'll get this equals root 2. We can now put that together in y equals mx plus c. Root 2 equals this, means c is equal to this, means the final equation is y equals minus root 2 minus 2x plus root 2 plus root 2 pi over 4 plus pi over 2. And that's your answer. Example 2. Find the equation of the tangent to the curve y equals e to the power of 3x squared plus 5x minus 2 at the point negative 2, 1. Giving your answer in the form ax plus by plus c equals 0, where a, b, and c are integers. So for this one, I'd jump straight into a chain rule. I'd say y equals e to the power of u, where u is that quadratic function there. I differentiate both separately, as we do in the chain rule, and then I would times them together to get dy dx. Simplifying this, we could put the 6x plus 5 in the front and then e to the power of u, which is this. And that's our derivative. We can then use that to answer the question. So let's sub in when x is equal to negative 2. Let's find out what the gradient, or dy dx, would be. Equals negative 7. So gradient is negative 7. We can now take that and put it into a y equals mx plus c, or whatever method you use to get the equation of a line is fine. And it would be 1 equals minus 7 minus 2 plus c, means c equals negative 13. Means altogether we've got y equals minus 7x minus 13. Rearrange that to the correct format that they want, and that would be 7x plus y plus 13 equals 0. And that's it. Last example, differentiate with respect to x, y equals 2 plus x cubed times ln 2x plus 1. So hopefully you'll notice that we'll need to use a product rule here because we have two distinct functions multiplied together. So with a product rule, let's say u equals x cubed and v equals ln brackets 2x plus 1. du dx is 3x squared, that's fine, but dv dx may require a bit more thinking. For something like this, I usually advise that you draw a line down your page and do a completely separate chain rule on the side. Of course, if you're confident, you can do this part in your head, but if not, then doing a completely separate chain rule is a good idea. So y equals ln u, where u equals 2x plus 1. dy du is 1 over u, and du dx is just 2. Multiplying those together, we get dy dx is equal to 2 over u, which in this case is 2 over 2x plus 1. You can then take that outcome and put it back into your main working out. So this is now equal to 2 over 2x plus 1. Definitely recommend having that distinct separation in your working out so that you don't get confused with which u is which and which v is which, for example. Then you can go ahead and do your product rule. So dy dx equals v du dx plus u dv dx. And this part is nice now that we have everything written out, just need to stay concentrating and insert the algebra where it needs to go. Tidy up as much as possible, and you get this for your final answer. That's it for now. If you found this video useful, please do remember to like, comment and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks, and see you next time.